We've made many enhancements to Screening Ultra in 2020 based on feedback from our early customers. Considerable attention has been made to further streamline the intuitive interface, both for end users and admins. Some of these improvements were introduced into 5.5 midway through the year, and others will become available in the upcoming 2020.1 release. Several improvements have been made to enhance the data entry experience in the upcoming release of Screening Ultra. It is now much easier to define replicates of the same sample and to validate the sample IDs against a reference database. Screening Ultra, and indeed classic studies before that, uses pre-configured plate formats to align sample information to date. We've listened to customer feedback and introduced greater flexibility in this area. As of 2020.1, users will be able to design plate layouts on the fly in the experiment itself, making Screening Ultra a more useful tool for when ad hoc situations arise. Coupled with improved graphical methods to input well and sample properties, which can be used in calculations or to group wells together, the 2020.1 data input wizard enhancements make it much easier for users to enter their data. In this example here, the plate properties are being used to define the antibody being screened. In this second example, the properties are being used to define the cell line and the cofactor. Another significant enhancement is the introduction of Python readers to parse plate reader files. These complement the traditional parsers used in studies, which work by finding the data in the files through regular expressions. Version 5.5 saw the introduction of kinetics to Screening Ultra, in which time response data could be processed and reduced to one or more endpoints within a well. 2020.1 will introduce improved interaction with the data and more support enabled by the introduction of Python parsers. For example, it is now possible to knock out the same time points across all wells and have the in-well analysis charted on a common axis scale. Previously, time points needed to be equally spaced, whereas now any interval can be specified using a Python parser. Additional plate statistics have been added, such as trimmed mean. We've also introduced the capability to calculate statistics for subpopulations of samples and controls. This allows much more granular control in building well analyses. For example, samples can be normalized to different control zones on a plate. Several improvements have also been made to the visualization of dose response data. Plate and well properties that can be used in calculations or to label and group samples can now be displayed on plots to add context to the results. The interface is more interactive than ever, with faster methods to simultaneously knock out wells across plates or to knock out multiple points on a curve at once. On the Trellis tab, where you could previously group overlays by results classification, results can now be grouped by these plate and well properties. The Trellis tab now features the ability to use a common scale for all plots and save all plots at once. To complement the enhanced capabilities of the analysis and Trellis tabs, a new analysis overview page has also been introduced. Whereas the other pages focus on a single result at a time, the user may switch between them. This new page shows all results for each sample on a single row with the representative plots overlaid. This provides a much more intuitive means to view multiplex data, where you wish to compare multiple tests per sample against each other. It's not just end users who will see improvements, though. A range of new features have been introduced for administrators, making it even easier to configure analyses and protocols. Inline search functions have been added, allowing users to pinpoint analyses, plate formats, or any other items of interest by text keyword searching. The range of functions has increased, and you can now nest functions inside each other. This greatly simplifies potentially tricky analysis configurations, such as this example of a qPCR analysis, where previously quite a complex equation had to be defined. With the new nested functions, this can be simplified to something that's much quicker to construct. The fitting engine has been improved, with users now able to control the fit optimization parameters which should result in better results when dealing with non-sigmoidal fits. And administrators can also configure classification profiles more easily by cloning existing configurations and recycling them. Additional protocol settings can be saved now. Some of these are completely new and some were previously global settings. The result is a much more flexible environment in which different protocols can be optimized for specific use cases.